Good evening, everyone. I hope everyone is able to hear me and everyone is able to see my screen. If possible, can someone please confirm if you are able to hear me clearly and able to see my screen?
Yes, sir.
Yes, sir.
Thank you. So, in the last class, we discussed about transaction management. So, what exactly we discussed is a transaction management is a unit of work that should maintain a consistency in case of my system is working correctly or system is not working correctly. In case of failure or in case of exceptions or in case of anything, we need to maintain the consistency on the data. So that is a typical usage of transaction management. As a part of database side, transaction management will completely handled by the database side. Whenever we start a transaction, it will create a temporary memory block. It's going to create a temporary memory block, and within the temporary memory block, if any database statement, DML statements are coming, all those should be part of this particular temporary memory block only. All these database statements are completely to be temporary memory block only. And if all the changes are done, if by default, if we say that if we are going to commit, if you say all they're good, the temporary memory block will become permanent block. Or if anything is goes wrong, the temporary memory block will be deleted. That is the internal design of a database management system. As part of Java developer, we need to manage few things before handling a transaction management. The first case is nothing but internally it is going to take care of. Okay, but exactly the first case is we need to tell the database system to start a transaction block. That's the first part. Okay, as well as we need to make sure that all the database statements should be propagated to the block, that block only. Finally, either commit or rollback to be updated to the database system. So Spring Boot is completely automated, where we have taken an example of a payroll processing of an employee, where employee should be created as well as insurance should be created. I don't want a employee is there but insurance is not there. I have an insurance but employee is not there. Like that, I don't want a situation. I want a transaction management. Like if employee is success, insurance is success. Then only I want to save the data. If employees fail or in insurance success, or insurance is failed or employee success, in either of the situation, we don't want to have any discrepancy on the data point of view. We don't have any uh, issues with the data. Okay, so that is how managing the transaction, which is a completely organization service, employee workflow. And we explain the code, like what we exactly we wrote a code is here. Typically we wrote inside that transaction management, we wrote employee service as well as insurance service as well as organization service. Inside organization service, okay, we wrote at the rate of transactional, that's a keyword, which is telling the database framework to create a transaction block. And I wrote two DML statements, employee service, insurance service, to be part of this block only. And if any error is there, it will roll back. If everything is success, it will commit. This is what so far I explained in my last class. Before I proceed further on today's session, anyone, any questions so far? As of now, anyone, any questions so far? I hope everyone is clearly able to hear me and everyone is able to see my screen, right, guys?
Yes, sir.
Okay. So everyone is clear, right, so far?
Yes, sir. Yes.
Thank you. So next point is we are going to discuss about propagation levels. Means how you want your transaction object should be created. Okay. In my employee insurance example, we are full commit or full rollback, assuming that within the transactional scope, I wrote 100 DML statements, DML1, DML2, DML3 up to DML 100. If I am writing 100 DML statements, okay, if I am writing 100 DML statements internally, typically what we are going to achieve is internally, if all are success, all are failed, right? If all are success or all are failed, I can achieve that only, right? But if you want any other behavior or if you want any scenarios where we need to think of a propagation level, little bit I am telling sir, this is a one of the I mean, I cannot say it's a board class, which may be or may not be useful in real time, but interview point of view, some people will ask, okay, out of my all the classes, this one little bit you feel as a boring. I'm literally telling you before I start the theory, but I'll make sure that I will add an entertainment section. It's not that simply let it bore. I don't want. Okay, I will add some entertainment section so that you will not get bored on that. Okay, right. Now, what is the first propagation level is required. The first propagation level is what required. Okay, if I don't write anything with a transactional, I only wrote transactional keyword, right? The default level is required level only. If I don't write anything near to transactional annotation, the default level of propagation is required. What exactly required is nothing but internally propagation is equal to propagation dot required. Propagation dot required. So this is a default annotation. Sir, what is the required means? Required means full commit, full rollback. That means required will make sure that only one transaction object will be there. Required is going to take care of only one transactional object. Okay. What do you mean by one transaction object? Assuming that in my example, organization service, right? As well as employee service, as well as insurance service. Totally 3 services are there, right? Yes or no? Now, as I told, I am going to add some entertainment. Okay. My entertainment is a father. Organization service is a father. He has 2 kids, son 1 and son 2. Who is son 1? Employee service is son 1. Insurance service is son 2. Okay. What is required propagation is maybe just 5 years before. How our Indian families works, or how Indian families traditions and the policies, principles and all the conventions that is required. Means father will say something even though you like or don't like, You need to follow. The king of the family is father. Everyone, either by hook or by crook, or good or bad, anything, by default, a father used to take care of completely about the family and all the issues related to family, right? Assuming that I am taking a scenario, a good father. If a father is earning, son one is earning, son two is earning. Okay, father is earning, son one is earning, son two is earning. Okay, what is the flow in a typical flow in olden days? If both the three sons are staying in the same house and all three are earning, a combined family, what they'll do? They will keep the money in one place and everyone will use that money. The entire family will use that money. Is that correct or wrong? In a
Yes,
typical,
yes, sons give to money to father.
whatever. But my point here is sons give money to father, and mother and father will collect the entire money and they'll spend that entire money to the family. So it's a combined family, right? In the similar way, if I have a transaction object at organization level, at a parent level, as well as transaction object at two kids levels. Transaction object means earning, something like you can think of. If my father is earning, that means organization service is having a transaction block. Son one is earning. Employee service is also having a transaction block. Insurance service is also earning. It is also having insurance transaction block. Org will have a transaction. Employee will have a transaction. Insurance will have a transaction. Totally three classes are going to have transactions. But ultimately, finally, what's going to have central point? Only one transaction should be there. Which one should be there? Who has a control? Father has a control, right? So what happens is the transaction object which is created at parent, it is alive. Even though you create a transaction object at child's level or not, no use. It will be completely ignored. Only one transaction object will be there that will be shared by these three services. Whatever org service do, that changes. Whatever employee service do, that changes. Whatever insurance service do, that changes. All will be collected in a central memory. And if any failure is happened, everything will be rolled back. If all are success, everything will be success. Only one transaction object will be created, right? In olden days, if son one and son two not earning, no use, no problem at all. Whatever father earns, that money will be shared. If son one is earning and son two is idle, no use, no issues. Son one will give the money to father and father will collect the money and that entire money will be shared to all the sons and father, which is the central reason for conflicts, right? The conflict will comes, right? When wives comes into the place, conflicts will come. Hey, my husband is doing hard work. Why we need to give a money to son two? He is simply idle. Our entire hard work, our entire blood is going. Why that guy is not having luxury? He should also do hard work. Some conflicts will come in a typical family, right? So just I want to compare same context here. What I'm trying to teach is if father is earning, son one is earning, son 2 is earning, or even father only earns, son 1 is not earning, son 2 is not earning, or any case, the entire money will be centralized and that money will be managed by the parents and they will circulate that money to the entire family, ARC service, employee service, insurance service, or employee father, son 1, son 2. In a similar way, if you have a transaction object at org level and you have a transaction object at employee level or insurance level, or both the levels are not there, simply it will ignore at child level. Only parent will be considered. So child 1, whatever the transaction object is there, it will give to parent. Child 2, whatever the transaction object it will have, it will give to parent. So parent will take these two transactions and it will make only a single transaction and it will control the data management. That is the first combination of required. Okay. Let me repeat here what is required annotation is. Now I'll ignore the example. Whatever the example for a sarcastic purpose I've given, I'll ignore that example. What is the real technical meaning of a required annotation means? In a typical situation, I have three services: organization service, employee service, as well as insurance service. Right? If I create a required annotation, by default, only one transaction object will be created and that is managed by the parent only. Parent only will create a transaction object and the transaction object will be shared between the sons or between the childs. Employee service is child 1, insurance service is child 2. Even though employee service, even though insurance service have the childs or not, or have a transaction object or not, even though they have no use, even though they don't have no use. So typically they will all share the common money and everyone will stay. That is a required annotation with respect to transaction management. Is it clear? Is that example make sense for you?
Yes, sir.
Yeah. So what exactly, now you can go through the example here. Okay. Here my scenario is, what exactly my scenario is. Organization service, employee service, right? Circle 1, organization service dot join organization. Circle 2, organize employee service dot insert employee. Okay. So at the rate of transactional propagation is equal to required. At the rate of transactional propagation is equal to requires new. Both the things are available here. Okay. So in case of required propagation, by default, both will manage a single transaction object. Okay. How it is going to manage? If parent is having a transaction object, a main transaction object is getting created. Even though you have a transaction object at employee level, even though you have a transaction object at insurance level, it will be ignored. If you don't have, it will ignore. If you have, it will be ignored. So it doesn't matter whether childs will have a transaction or not. Whenever required annotation is there, completely the transaction object is at all services inside that particular how many DMLs I'm going to call. So it is responsible for all the services. Only one transaction object will be created, full commit, full rollback. So that is typically taken care by required annotation. Anyone, any questions so far? So in this example, what I'm trying to say, if employee service is having a transaction, it will ignore. If the employee service doesn't have a transaction, it will ignore. In any of the situation, kids or childs are dependent modules does not have any adverse impact on the transaction management. If they have, they will participate. If they don't have, they will ignore. So this is a typical situation of requires propagation. Clear, everyone? Any questions here? As of now, any questions?
So, sir,
Mhm.
now every service calls the transaction. Fundamentally creates a transaction if it does not exist. Is that bottom
What is
line?
it actually? Your voice
The
is breaking actually. Okay. Can you repeat? Actually, your voice is little bit breaking in the middle.
okay. I'm sorry, sir. So, are you able to hear me? Okay,
Yeah, yeah,
still
clearly.
break.
Yes.
Okay. No, actually, so my question is, calls always calls the transaction, and that holds the control of whether it creates the transaction or if it is not existing, or if it is existing, it will reuse the transaction and it just ignores the transaction at its child level.
Correct. Exactly. So
Thank you.
completely parent only will create. In which way I call parent, in which way I call child? I'm calling employee service within organization service. I'm calling insurance service within organization service. For me, organization service is a parent and employee service insurance service is child because they are called inside organization service.
Yes.
Yeah. So this is the most widely accepted strategy. Full commit, full rollback. For example, in organization service, in real time, lot of services are right. Employee service, insurance service, provident fund service, gratuity service, leave service, HR service, code repository service, project repository service, DevOps service, QA service, project management service. All these are typically having internally, and every microservice is going to have different tables, and we are going to have a collaborated architecture, which is a microservice architecture, or we can call that as a transactional, where we are going to take independent tables and we are going to achieve. Parent is organization service and all the remaining services are chains. That is a typical description of required. Everyone is clear? Any questions on required understanding?
So basically, parents only. The parent class is the only one that can either commit or roll back the transaction, and
Correct.
we cannot commit or roll back the part of the transaction.
Yes, we cannot commit the part of the transaction. Okay. But there is a one more combination going to happen. Okay. The combination is, maybe I'm going to take it. One second, guys. So what is that I'm going to refer is, yes, you're able to see that, right? Now a transaction object is required. Organization side required I wrote. Employee service also I required I wrote. Insurance service also required I wrote. Even though I write it 3 places, only one transaction object, correct? The first row is correct, right?
Yes.
Yes, sir.
Second row. What is my second row? Required is at parent level, but I didn't wrote anything in the child. I simply didn't write anything in the child. The same code what I typed here. Okay. Srikanth Kumar. Mr. Srikanth. Yeah, thank you. So by default, the same code what I wrote here. I wrote transaction annotation only at org service, right? I didn't write anything in the employee. I didn't write anything in the insurance. Am I right? Did I write any transaction annotation? Only org level only I wrote. The same combination, right? This is whatever I typed in the class. Is it? This time also only one transaction object, full commit, full rollback. If employee success and insurance is success, then only data will be saved. If any one of the things are failed, everything will be failed. Now I have a one more combination. What is that combination is? Okay. My organization service, I am not writing anything. NA. I'm talking about this case, guys. I'm talking about this case. My organization service, I'm not writing anything. But employee service, I'm writing required. Insurance service also I'm writing required. What happens here? What going to happen here internally? Can someone guess?
If you make a call from organization service, then it does. Actually, the transactional
It will
service
ignore.
will not occur. Will not happen. Actually, the framework will not manage the transaction at the organization service level.
Yes. But what is going to happen? First of all, the point is correct. It framework is not going to manage the transaction at org level. But I wrote the same transaction object at employee level. I wrote the same transaction object at insurance level. What is going to happen? Means employee one transaction object, insurance one transaction object. As long as my father is earning, I will listen to him. If my father is not earning, no transaction object. Son 1 is earning, son 2 is earning. Anyone cares about the father? I will have my own life. Son 1 will say that I'll have my own life. Son 2 will say that I'll have my own life. No one cares about father. Am I right? It's a truth. As long as father is earning, everyone will be under one control, only one transaction object, everything will be shared. Whenever only a small change, if I don't have transaction object at a parent level, if my father is not earning, if son 1 is earning, son 2 is earning, what happens here? Means two transaction objects are created. One transaction object is at employee level, another transaction object is at insurance level. If employee fails, insurance success, no issues. Insurance success, employee fails, no issues. Employee is in different transaction, insurance is in different transaction. When father is managing my entire family, if son 1 having a problem, son 2 will help. If son 2 will have a problem, son 1 will help. If father is having a problem, son 1 will help, son 2 will help. It's a collaborated family. But whenever it's splitted, father is staying in one house, son 1 is staying in another house, son 2 is staying in another house. In this situation, son 1 got any problem, can son 2 will come? No way. When father is having a problem, son 1 will come? No way. All are isolated. Son 1 family have problems, son 1 should only take care. Son 2 family got some problems, son 2 family only should take care. No one will enter and no one will help. That is the required annotation with respect to where if parent is not managing the transaction. If parent is not at all managing the transaction, then a different transaction objects will be created. Two transaction objects will be created. One is at employee level and another one is at insurance level. If I'm talking NA required, only one transaction object at child level. So these are the four combinations we can use in real time. Are you clear on these first four scenarios? Which one I wrote, what exactly I wrote? Is it going to impact anything or is it going to achieve anything? Is everything is good?
Sir, I had a one quick question, sir.
Mhm.
In the number 3,
Yes.
line number,
Yes.
that's right. So let's say that the transactions started separately for employee and insurance,
Mhm.
and let's say employee inserting record is failed, then it only roll back only employee record, right?
Correct.
And
Exactly.
insurance will still succeed.
Correct. It is independent, completely independent.
Yeah.
For example, in
Yes.
employee service, I'm writing 10 database calls. In insurance service, I'm writing 5 database calls, assuming that any employee failed, those 10 will be rolled back, but 5 will be committed. Whatever happens to employee, it will not propagate it to insurance. Whatever happens in insurance, it is not propagated to employee. A typically new lifestyle. Okay, father will stay in one location, son 1 will stay in another location, son 2 will stay another. Everyone is isolated. No one doesn't care what exactly they do. If at all, if father is not
So I
controlled.
think the
Yeah.
most ideal scenario would be the first one, right? Whether you
Correct.
could use in at any level.
Yes. Ideal scenario is first level or second level. Both are same, right? Even though you use transaction at kids level, child level, it may be if you use it, will ignore. If you don't use it, still okay. So first two levels are real time scenarios, which is going to manage only one transaction object at any point of time. Clear?
Sir, one thing like if the required is at the parent level, then only if anything happens to child level, it will be handled by the organization service parent.
Correct. Exactly.
But if it is not there in the parent level, the
Both are
transaction will
true.
be separately maintained by the child level
Correct.
transaction, right?
Yes.
Okay.
Yes.
Got it.
Correct. So you should think of a father and son, two sons, and whatever the real time scenario which we are discussing, how father behaves, how son behaves, how son to behaves, like that only this situation. Okay.
Sir,
Right.
is there any concept of partial
I'm
transaction?
going to, yes, I'm going to
Okay.
explain.
Okay.
That is requires new means, sir, in service, employee service, I have 100 database calls. In insurance service also I have 100 database calls. In organization service also 100 database calls. Totally org level 100, employee level 100, insurance level 100. Total how many calls? 300. What I want is typically I have one statement each: employee, insurance, arg. Remaining 99 should roll back, but 3 statements should commit in case of success or failed, which is called as a partial commit, partial rollback, which I'm going to explain with one annotation. That is what I'm going to focus on after these isolations are over. Then I'm going to teach them. That is partial commit as well as partial rollback. What do you mean by partial commit? Means committing the data to the tables, partial commit, rolling back the tables whenever an issue comes. So partially it will commit, partially it will roll back. Is it clear? I'm going to explain that scenario also. As of now, any questions so far? Is everyone is clear so far?
Yes, sir.
Okay. Next is I'm going to talk about the next annotation is supports. Okay. What exactly supports means? Supports is a separate case where if my parent is earning, then only kid 1 support, kids 2 support. I listen to my parent only if he is earning. If my parent is not earning, can I listen or can I support? I mean, just to understand the picture in a better way, I explain that example. Sir, I'm not generalizing. A most frequently accessed father son's relation when money comes into picture, I'm explaining. Okay. But it may be same with every family. It may not be same with every family. Just to make sure that you should understand this example clearly, I'm sarcastically quoting this example. It may be correct, it may be wrong also. Okay. Right. In case of supports means if my parent is having transaction object, then I'll participate in the transaction. If my parent is not having any transaction notation, I'm not going to enter. It all depends on whether parent is writing transaction object or not. Okay. If parent is having transaction object with required annotation and supports is there, it will still participate in the same transaction. If the parent does not have any other annotations, typically it will be out of transaction and it will not managed by the transaction management. Employee will take care of its own transaction. Insurance will take care of its own transaction. And no central point will not be there. So what exactly supports? As long as my parent service is up, its use. If the parent service is not up, what is the difference here? In the previous example, in the parent service is up, okay. I'm not writing any transaction. I'm writing required here. Employee will have its own transaction. Insurance is going to have its own transaction, right? If the parent does not have a transaction, required is going to create a new transaction. If the parent is not having any transaction at all, still you use required annotation at child level, it will going to create. Required is always creates a transaction object. But whereas in case of supports, if you see a required supports only one transaction only, because arg is parent, already required means transaction object is there. Kids 1 support, kid 2 supports, only one transaction object, combined family, everyone will listen. other. Second case is required supports NA. I'm not writing anything. At that time also, only one transaction object. But the problem is, in case of supports. In 3 layers, I wrote supports. No transaction at all. Because my organization service does not have any transactional boundary. It's internally having employee service, it's internally having insurance service. That is completely managed by the framework. Required supports only one transaction object. Required supports NA, which is one transaction object, which is the parent level. But supports no transaction. Supports is not going to create a transaction. If I am idle, father is idle, son 1 is idle, son 2 is idle. No control, right? No data, no money, no transaction. But in case of this scenario is differs. In your parent, you don't have any annotation, but in child, you write supports. If the parent is not supporting, you don't have a transaction at all. In case of required, it will create. Employee will create its own transaction. Insurance will create its own transaction. But in case of supports, it's not going to create, which is org level NA, insurance level supports, employee level supports, only no transaction at all. Supports required. Supports means no at parent, but required is going to create, right? So employee level one transaction and insurance level one transaction. So this is a matrix which is with respect to supports. The difference between required and supports is, in case of required, if the parent doesn't have a transaction, in the child, if you are writing, it will create its own transaction block. But whereas it's in supports, if parent is having supports, child is also having supports, then doesn't matter. The transaction will not be created and it will not be shared. Only someone will take that transaction object, it is going to share. Is that clear, everyone? There's the only one scenario which is the required as well as supports. Any questions so far? Anyone? Any confusion? I told little bit of boring, but at the same time, I mentioned that I am going to add something sarcastically to make impressive on this. Everyone is following clearly, right? Any specific questions as of now?
So what is the difference between the third one and the fourth one?
Which third one? Which fourth one? I didn't
The
understand.
third, like any parent is having the any and support both the child is having the.
This
No,
one?
I'm saying yes. Not sure. Yeah, this one. No, sir. In case of support, I'm saying
Okay. In case of support,
the third and fourth. I'm saying yeah.
no transaction. I mean, I'm not, even though I write parent level
Hmm.
or not writing anything, any parent, no transaction at all. No difference at all.
Both the cases it will look like same, right?
Same, no transaction at all.
Okay, sir. Thank you.
Yeah. Any other? One second, guys. I'll be back in 1 minute. 1 second. Okay, guys. Yeah. Any other questions, guys, before I proceed further? On required as well as supports. Everyone is clear?
Yes.
Okay.
Yes, sir. Clear.
Yep. Now I'll take another scenario, which is not supported. What I'm going to take care is typically a not supported scenario means, sir, even though your father ends or does not ends, I'll keep isolated. I don't care. I always want to be separate. I don't want to stay in the combined house. I'll not support that idea. Even though you write propagation required at a parent level, if you are not right, if you are writing at an employee level not supported, it will not participate in the transaction block at all. It is not going to participate in the transaction block at all. Supports means if parent supports, child supports. If parent doesn't support, child doesn't support. In case of not supported, even though you write transaction object at parent level and child level, if you are writing not supported, it will ignore the transaction object. Employee will never participate in the transaction. In case if you want to write any code outside of the transaction, maybe organization service is having 10 services: employee service, gratuity service, provident fund service, HR service, project code service, or any other things typically. Okay. If you want one service to be out of transaction, you will write that service as not supported. It will be completely out of transaction. It will not participate in the transaction block. Understand? So every time transaction object is not there. So we'll see here third scenario here. In case of not supported, I wrote in the parent level required, not supported, not supported. Only one transaction object at parent level, correct? Required, supports, not supported. Maybe I'll keep hide on this. Maybe we'll discuss this. Okay. Now required, not supported, not supported. What happens, guys? In parent level, I wrote required, but employee level, not supported. Insurance level, not supported. Only transaction will be applied here only. One transaction object is created, out only here it will apply, right? Required, supports, not supported. What happens here in this combination? Anyone can guess?
Yeah.
One transaction.
Employee will participate in the transaction, but insurance won't. Or
Correct.
both will be participated.
Yes,
because
these two are in one transaction block. This is not supported. Insurance is out of scope. Whatever fails in org or whatever fails in employee, both will be rolled back or both will be committed. Insurance will not be impacted, right? Not supported, required. What happens here? In the org level, I'm telling not supported. It is not part of transaction. Employee required, insurance required.
it's same as before, like two
Transaction.
separate transactions.
Correct. Two transactions, separate transaction. Employee will have its own transaction. Insurance will have its own transaction, right? Supports required, not supported. ARG supports. Employee is required. Insurance is not supported.
Just
Only one
employee will
transaction will be created.
Exactly. Employee only will create. Insurance anyhow not there. Organization anyhow not there. Not supported, not supported, not supported. No transaction at all. Right? So clear everyone? So let me repeat here what exactly I discussed so far. Okay. There are three propagation levels I discussed. Required, supports, not supported. What is required? As part of required annotation. Okay. As part of required annotation, only one transaction object will be created at any point of time. Only one transaction is created. If a transaction object is created at parent level, it will be applied automatically at child level. If the transaction object is created both at parent level as well as child level, then completely it will be ignored and only one transaction object will be there. Okay. In case of supports, if a parent supports, child supports. If the parent doesn't support, child will not support. So at parent level, if the insurance is not there, even though child level you are trying to create, it will not create. So that's the difference. In case of not supported, even though you write at a child level, you're not going to support at parent level, the child will be completely ignored. So this is three cases which I discussed here. Maybe I'm going to share the spreadsheet. Transaction management. Still remaining three things I'm going to focus tomorrow. And tomorrow I'll explain partial commit, partial rollback. Understand? Partial commit as well as partial rollback also I'm going to explain in tomorrow class. Okay. Right. Fine. Thanks everyone for today. Have a great day. We'll meet tomorrow. Have a great day. Thank you all.